Thanks, Fred, and welcome everyone to the very last session of the day. I think in some areas and some countries you're fairly early on in the afternoon, but I'm predicting that I'll be finishing up about 7:15 in the evening. And at a PITA AGM, that's typically when we start cracking open a few beers and having a few drinks and nibbles. That won't be happening, unfortunately, but we'll figure out a way to get that happening next AGM. But it wouldn't be an AGM meeting without a dedicated session on satellites. They've been the mainstay of many of our Pacific Island networks for decades, and that doesn't look like it's going to slow down either. So there's a lot of technological advancements we're seeing in the space segment. So it's appropriate that we get the update. There'll be a slight change to the order of presentations. Sds Southern Cross will start off with a combined presentation due to other commitments. But we have the usual group of presenters who've got a lot of experience in this segment of the industry. So it's going to be interesting to get the very latest updates. So I'll hand the virtual podium over to Alan to lead, and then we'll work through the rest of the agenda.
Thanks, Phil. Good afternoon, everyone. To see you virtually. Obviously, we would have liked to have done this in person, and enjoy the bilaterals and, of course, the networking events. I miss being able to travel out to the islands. I miss, the stories that we shared. I miss the recovery, fresh coconut juices in the morning. But hopefully, we get to do this all again soon in person. So, yes, today I'm going to be talking a little bit about what we've been doing to help bridge the digital divide. Talking a little bit about Mpower, and we've actually invited a special guest as well to have a bit of a chat about what we'll be doing and what we're collaborating with. Now, COVID. Obviously, it's had a huge impact on everyone over the past 15 months or so. It's changed the way we work, learn, live, and play. It's had a huge impact on economies globally. The Pacific nations, they're heavily reliant on tourism. Obviously, with the border shut, it has had a huge impact on economies there. But when we're talking about new opportunities and in these new realities, we can see that COVID is in somewhat actually has leveled the playing field, because we've seen and we heard from our presenters earlier on today that people are working from home. So there's no difference from someone working from home in New York City to someone working from home in one of the islands in the Pacific. We all have the opportunity to go and do work. But what that's done is it's placed an even greater priority on connectivity. And it's also introduced somewhat of a digital divide. There are nations that are fortunate to have received undersea cable. There's been a lot of activity over the past couple of years, as we've seen, in the Subsea Cable Forum earlier today, with the proliferation of cables rolling out throughout the region. But there are some that are less fortunate, that don't have a cable connection to their country, or they don't live on the main island. And so there's been an even greater digital divide in place now that your main populations have fantastic undersea cable connectivity. But the residents on the outer islands, they don't have that same privilege. So there's a whole heap of innovation and investments in the satellite space, in particular, that we're hoping to help bridge this digital. I'll talk a little about Mpower, and Rob will talk a little bit more in detail around that. But we've made some developments there in terms of the technology in the antennas, in the ground infrastructure, in the whole ecosystem. So we look forward to telling you more about that. So I'll recap a little bit about what's happened in the Pacific over the past 10 years or so. You know, before 2014, the majority of nations in the Pacific only had access to geostationary satellite connectivity. Look, it was great for the time because it was the only option available at the time. We came along in 2014 and began our operations, and we brought in our low latency LEO connectivity. And you know, we're very proud and very grateful to have played a role in bringing economic development in the region, in providing connectivity for, you know, in health, in government, education. But, you know, we've somewhat become a victim of our own success in that we've spurred economic development, and that has brought a number of nations to a stage where cable has become feasible. You know, there's increased requirements and expectations from residents, and that has led to a proliferation of cable connectivity. We've seen and played a part in the evolution of networks. I mean, you know, back in the day, it was just 2G connectivity, voice and SMS. But now we've seen the evolution to 3G and 4G LTE networks, and we've seen the discussions about 5G as well. And then moving on to the future, you know, we're really excited about, you know, NGSO constellations. Obviously, we've got our play in Mpower, and we'll talk a bit more about that. But at the end of the day, I've said this before, competition spurs innovation, and that ultimately leads to the benefit of, you know, residents in remote places that really stand to benefit most from connectivity. Okay, from a technology perspective, you know, we've had the fortune of having a bit of a head start. You know, we've been playing around with non-GSO since 2014, and we've learnt a lot of, overcome a lot of challenges on the way. We've learnt a lot, gained a lot of valuable experience, and we're looking forward to bringing the next generation of hardware and infrastructure. So, you know, everyone talks about the holy grail of antenna technology being flat panels or phased array or electrically steerable antennas. Obviously, we have, you know, put a lot of development into that space ourselves. We've invested in 3 different companies just to diversify. And, you know, obviously, not all companies are going to bring out the same type of technology. One of them is bringing out a technology based on similar to LCD TVs. But, you know, they have differing timelines, different performance capabilities, and also different commercials around what they actually cost as well. So they will be suited to different markets. But the important thing to note is, you know, we have technology with parabolic antennas that are available today. And, you know, the LEOs, they're investing in this space as well, putting a whole heap of money in antenna development with the flat panels. And as soon as one of these companies brings out a commercially feasible flat panel, then we can jump on that and give access to our MEO customers and new potential customers to the same technology as well. What we've learned during these past 8 years also is not just about satellites in the sky, it's about the ground infrastructure as well. And we have put a lot of thought into our next generation Mpower platform, and we've listened to our customers, and we've you know, opened up some new possibilities and flexibility there. And you'll hear Rob talk about that. It's always nicer when you've got an engineer talking about things and not a salesperson. I think it's always easier to believe. So I'll let him do the heavy articulating so that the dumb sales guys like me don't spill too much disinformation. So we are developing ground terminals. These are going to be integrated units, software integration, intelligence, edge computing. it's all going to be part of a simpler network for our customers and opening up more capabilities as well. We're the founding partner with Microsoft's Azure Orbital platform. So there's obviously a very heavy push from our organization to align closer to cloud and bring more capabilities to our customers as well. So we do use industry standards, do work with major operators, not just Microsoft, obviously, Amazon, and the large content providers as well. So I'll move on to our schedule. So really excited about this. We're fully on track to launch Q3 this year. We've expanded our constellation of satellites from 7 to now 11 satellites. And we will be in operation Q3 next year. Obviously, we're fully funded, so this is going to happen. And we heard from Stuart early this morning at the beginning of the day. For those of you who attended, he is the person responsible for delivering on the promise of O3b LEO. Our visions, so our founders had a vision, and he was responsible for bringing that vision to life. So, you know, we're very confident in him leading this O3b Mpower program. You know, we've had the experience there. We're very, very confident that this is going to provide connectivity to even more of the world. So what does this actually mean for you? So I'll hand over to Rob, and he can tell you more about it.
Hi everyone, I hope you can all hear me. I'm going to ask Alan to drive the slides, and we're just going to run through some of the technical details on the Mpower system, and then some of the value proposition that Mpower brings specifically to the Pacific Islands. I mean, as Alan said, we've been very, very fortunate to be, you know, a member of the Pacific Islands community. You know, we've provided you know, a lot of connectivity. You know, the landscape is changing. You know, we're seeing the cables come in, we're seeing that operation move, and you know, we fortunately have had some influence on, you know, what Mpower will bring to, you know, places like the Pacific, you know, and make sure that, you know, it's fit for purpose. You know, we really want to make sure that, you know, we can now leverage the existing technologies and, you know, really advance from where we were with the O3b classic constellation, as we're calling it. Alan, next slide, please. Thanks. So I'm just going to do a bit of a recap. I'm pretty sure that most of you know this, but you know, I just want to make sure that, you know, we're all on sort of an equal plane here with terms of our orbits that we operate in. So obviously geostationary, this is our legacy operations that SES has sort of been working in for a very, very long time. Geostationary satellites at 36,000 kilometers, a very large view of the Earth. You know, we only need 3 satellites to actually illuminate the whole Earth's surface. And because of that distance, you know, we do really have you know, this 600 to 700 milliseconds round trip latency. And, you know, geostationary satellites very much have their place in the connectivity play, you know, globally, and especially in the Pacific, because we can cover a very large area, and we can connect that back into, you know, very continental gateways or you know, very, you know, regional gateways. Then we go to our LEOs. So, you know, we've all seen the Starlinks and the OneWebs, and you know, we've got Telesat coming in as an operator. You know, the Amazon with the Kuiper project. Again, you know, very low latency that they're touting. You know, between, you know, 50 to 100 milliseconds. You know, I think that 50 milliseconds is the average. But because of the orbit being sub 1,000 kilometers, you know, we've got a very small view of the Earth. Now, that in order to sort of expand that capability, you know, the LEO operators need to have a large number of satellites, okay, and they need to operate, you know, a large number of gateways. SES did look at investing into a LEO constellation. We did do our due diligence on a LEO network, but we felt that that investment was best suited towards our existing MEO orbit, and you know, really focusing on getting the next generation of MEO satellites to provide that connectivity. So MEO at 8,000 kilometers, 8,062 kilometers to be precise, we typically provide latencies of around 150 milliseconds, and we've got coverage now between 45 degrees latitudes. We're extending that to 50 degrees latitudes with the Mpower constellation. But what this does is that, because we've got access to this spectrum, you know, the full Ka spectrum, we can provide very, very high throughput at this 150 milliseconds round trip latency to a very wide coverage, you know, not as wide as the geostationary satellites, but, you know, a lot wider than a single LEO satellite, okay? Therefore, we don't need as many satellites in our constellation. Our satellites, the O3b satellites, are equatorial, in an equatorial orbit. And with the Mpower satellites, we're actually going to interdisperse those with the existing O3b constellation. So we run about 20 satellites on the O3b Classic constellation now. And when we're at full complement on the Mpower system, it'll be another 11, so 31 satellites in total. Next slide, please, Alan. So just a quick recap on you know, our beams. So we do operate both spot beams on both the O3b Classic constellation, what we've got today, and we will be operating the spot beam technology on the Mpower satellites. The key difference here is that because we're using a flat panel antenna system on board the Mpower satellites, we're able to use a what we call beamforming. So what this means is that, you know, the beam creation will be fully digital. We're able to group clusters of phased array elements in order to recreate beams on the ground, which are very scalable, very dynamic. That being said, they're also a lot smaller, okay? So our beams range from 700 kilometers in diameter on the O3b Classic. We can cover very large areas of the globe. You know, we've got, we can also cover, you know, multiple locations in the same beam, and we've done this throughout the Pacific. Now with Mpower, we're going to take a different tact, and we're going to move away from that large sort of coverage area to very focused spot beams. So where we put a terminal down, we will land a beam, and then we can allocate capacity within that beam as we need to. And the Mpower beams being around 250 kilometers in diameter. Okay. So what this means is that each of the Mpower satellites can have up to 5,000 beams available. Of course, we're not going to use 5,000 beams in one sort of region, but, you know, we can group those beams together to make, you know, put larger amounts of capacity into a smaller 250 kilometer beam. Thanks, Alan. Next slide. So as I mentioned, the Mpower satellites are fully digital. All the payload is fully digital, which means that we're able to connect, you know, beams to any beams at the moment. When we compare that with the O3b Classic constellation, each of the beams is connected through to one of our gateways. We still operate that model on Mpower, but we're now able to produce different connectivity options. We no longer have a gateway beam per se, but we can allocate capacity over one of our gateways and at the same time over one of our terminals. And what that means is we can then interconnect those two. The key feature that we can really bring to the Pacific here is that we're now able to operate domestic low latency gateways. So, for example, on the main island in you know, an archipelago, we could put in a you know, a medium size or a large Mpower gateway, and we can connect each of the remote islands back into that main island, back into the core network using the Mpower and low latency constellation. Okay. Each one of these beams, like I say, is very, very scalable in the capacity that we can provide, and also the power that we can provide into that beam. So we're looking at things like rain fade detection. We've got a resource control software that can actually you know, interrogate the links and adjust via our ground telemetry, you know, satellite systems, ground-based systems, uplink power control, modems, frequency, symbol rate. Okay, it's all very scalable. We're no longer tied to sort of a fixed forward to return ratio, so download to upload. It's very scalable. Again, you know, we can make it a 1:1. You know, maybe we're looking at a cable backup system where we, you know, we need to, you know, adjust the throughput, or, you know, we're looking at even government applications where we may even have more return or more upload capability. You know, it's very, very scalable. Still at the 150 milliseconds round trip. Next slide, please, Ahmed. So when we look at you know, the coverage of the Pacific, you know, we can sort of start to look at be very, very focused in where we provide our capacity. Again, you know, we can connect, and this is just a sample. You know, we can connect any one of these beams back into our own regional gateways. We'll still have our O3B gateway in Sunset Beach in Hawaii, and we're also got building a new Mpower gateway at our facility in Dubbo, New South Wales, Australia. So we can connect any one of these beams back to those two gateways, or we could connect them back into a regional gateway. And as Neville will sort of talk about a bit later on, you know, the model that we're sort of looking at is, you know, really extending that last mile connectivity from, you know, maybe the cable landing station out to those outer islands, and really giving everyone in the outer islands, you know, that same level of service that the main islands, the main island residents enjoy. Next slide. So in terms, Alan sort of talked about terminals before. We have spent quite a bit of time and effort in looking at, you know, what we're putting on the ground in the islands. You know, we're very, very conscious of, you know, the first generation of hardware that went into the islands was very much that first generation. You know, we've learned quite a lot of lessons around that, and we've opened up our terminal design to, you know, much more, or a few more manufacturers. You know, diversity is the spice of life, and, you know, the more people that can provide this type of equipment, you know, it's just flows on to create a better service and, you know, a lot better pricing. That's for sure. So we're looking at, you know, new maritime terminals. We've got tri-bands available. We've got, you know, small 0.85 meter maritime terminals. You know, maybe there's some ocean-going vessels, you know, in between islands that, you know, would like to have connectivity. Then, you know, we can certainly do that. But more importantly, you know, our fixed data terminals are now, you know, we're extending that range, and we're ranging again from 1.2 meter terminals all the way up to 3.7s, and, you know, even the larger 5.5 meter terminals. So all of our gateways use the Comtech 5.5 meter Ka band antennas. They are available for, you know, domestic gateways, or we could go with, you know, maybe it's a smaller 3.7 meter terminal. Okay, we do know that there's quite a few of our 4.5 meter tier 1 antennas out in the Pacific, and we have a plan, you know, in order to retrofit those to be Mpower compatible as well. Then we get into our emerging technologies, and then Alan hinted at some of the developments that we're doing. Definitely flat panel antennas is the future. We've invested in quite a few companies in order to sort of develop those. We're hoping that the first production units will be ready in time for the Mpower launch. We certainly anticipate those a lot. One thing that we sort of didn't really put too much emphasis on is our modem technology. So we are developing or have developed 2 new modem platforms for the Mpower system. They're both based on, one is based on the Galat system, the other one's ST Engineering iDirect. Very, very scalable in the throughput and the capacity that we can provide. Very high throughput. We now can offer, that 1.5 gigabit per second mark to a single terminal, or we can have as low as 50 megabits if we need to. The one thing that we also had with our O3B Classic system is that we really needed that business case for a beam, and it was very hard for us, I feel, that to bring capacity, especially small amounts of capacity, into an island where we need, both of us, SES as a supplier and the customer, needed to have that business case. This kind of disappears with the Mpower system because we have so much resources available on the Mpower satellites in terms of beam, power, and smaller terminals. We can start to land services, at much smaller throughputs. Next slide, please, Anna. So I'm going to sort of run through some of the value proposition and the use cases for the O3B Mpower system, and I think the first one to kick off really here is the island nations. We're really targeting the outer islands, those islands that maybe have a geo connectivity, and it's not it's still not cost effective enough to maybe to get those higher throughputs that the population would like to have. Mpower can solve some of these issues, because we do have that scalable throughput rate. We're also able to have so lower cost terminals and more suited to island locations, and be able to sort of provide that connectivity, that low latency connectivity. We can also, now using the Mpower system, connect that back into a domestic gateway, meaning that we can really connect those larger, those islands that are further away, back into the same core network without actually having to go through maybe an SES gateway and then come back via fiber. We can have that single hop connectivity. Okay. We still operate, multi-gigabit constellations or multi-gigabit throughput if we need to, and we can really scale and dynamically change the throughput based on the demand for each of those individual islands as we need to. Next slide, please. So the next one, and I know that we've sort of touched on cable backup, in the past, but we're really this is something that is dear to our hearts, because we have been in the Pacific. We have been that sort of primary trunk provider. We have seen the cables come in, and we still see the need that those cables, especially the single thread cables, will require at some stage a backup system, and Mpower can help solve this issue by providing that scalable capacity as we need to. We can scale up to multi-gigabits for a single terminal if we need to, but we can also, during times when the capacity is not required, distribute that throughout a set of wider network, maybe the outer islands as we need to. Okay, our forward to return ratios are very, very scalable. But more, I think the real key feature here is that, we have the ability to be able to ramp up this capacity in a very, very short period of time. With the Mpower system, because we are tied in with a resource control system at both our gateways, the upstream providers, and the satellites themselves, we could set up a system where we could ramp up this capacity in a matter of hours to complement, maybe the fiber break if it's ever happens. Okay. Next slide. So digitalization, this is maybe where we've, sort of still relying on, access technologies in remote locations to, provide that same level of connectivity, for the 3G, 4G markets, okay? Being able to move that capacity out to those islands. Maybe it's a advanced deployment for towers for a 4G network rollout, for example. Next slide. And I think I've just seen the note to sort of speed it up a bit. So I will just again, Mpower, we're able to provide those throughputs and the latencies that can enable sort of 4G and 5G technologies. And this is really important when we're looking at locations where we're deploying maybe new towers and new networks. Next slide. And I just want to finish off my section on disaster recovery. And I think this is, something that's, we're all aware of, but it's something that maybe we haven't quite planned for. So with Mpower, again, we are able to repurpose capacity as we need to, and we're able to do this in locations very dynamically. We're able to do or shift capacity around, based on demand. And we're looking at a system where we give users a portal system. Essentially, you'll have your terminals available for view, and your capacities assigned to each terminal, and then ultimately be able to shift capacity around as you need to. If we're looking at disaster recovery, then how do we actually have terminals? We've got transportable terminals that can be packed up and shipped out if we need to, or stored away. We're also looking at now comms on light vehicles and comms on wheels that can be rolled out in a very very short period of time. So with that, I'm going to pass over to Neville Hankey from Southern Cross Networks, and go from there.
Thanks, Rob. Thanks for that. Look, my name's Neville Hankey. I'm the Manager of Technology and Customer Support for Southern Cross Cable Networks. Been in the industry for over 30, maybe closer to 40 years in international communications, back in analog cables and in satellite. I want to thank Alan and the team for inviting me today. That's probably the first thing that people ask is, why would a subsea cable guy be a guest of the satellite guys? And even sharing a presentation on the stage with them. I think, well, between us today, with both Rob and Alan mentioned, we work together, and I wanted to dispel that old paradigm that satellite and cable are in competition, because we really are very much in complements with each other. With a mesh of technology and really around what it can bring to like the Pacific region in the way of capacity, reliability and performance. And as Alan mentioned, with COVID-19, even highly populated cities have now realised about the importance of connectivity, and it's given those big smoke people the idea of what happens in the regions where it doesn't matter whether you're in London, New York or Sydney or one of the islands, the cultural change is really that connectivity is really needed for everybody. So I'll move to just give you a bit of a background. I know this is not a cable preso, but it's probably good just to give a little bit of background on us and how we fit in with the satellite community. Next slide, please, Alan. Thank you. Okay, so this is our network. As many probably do know, subsea fibre brings ginormous capacity to the Pacific region through backbone networks like ours and others. And I guess if you're basically on the direct path between Australia, New Zealand and the US, and those islands actually get to benefit from subsea cables. And I guess we've been around since 2000, and what started as a 20 gig system, originally designed for 120 gig, is now running over 12 terabits. So when we talk about capacity, that's a 300-fold increase in just on 20 years on the same infrastructure. We've had quite a few firsts in that time. The first to implement 40 gig and 100 gig wavelengths from Sienna, and recently we're the first commercial operator to successfully run 800 gig wavelengths on our network in the US. So this is just showing the blue lines where we are. I have shown a few of the green lines, which show some of those regional cables that we talk about. Next slide, please, Alan. So what's next? Good pun. We are building a new cable, as probably most know. It's due to be finished in the end of this year or Q1 next year. This is just showing the new cable stations. So Auckland, Sydney, Fiji, 2 in Fiji, Suva and Savasavu, Tokelau, Kiribati, and also this one's going in towards Los Angeles data center. Thanks, Alan. So this diagram is very similar to the last, but it does just give a bit more idea about those regional cables that I just mentioned. So from other presentations, just to probably note a few there, that the Manitoua cable, the French Polynesia, the Honatua cable down to French Polynesia. We've got the ASH American Samoa, a couple out of Suva, the Tui Samoa and the Tonga cable, and the Vanuatu cable, known as ICN, and also the green one right over the left is Gondwana, which is to New Caledonia from us in Australia. There's a few other cables there not mentioned, as well as some other backbone cables like RTI and Hawiki and TGO, which don't connect to us, but probably are for that same function. So similar function, not quite as ours. So thanks. Next one, please. So this is a snapshot of what our design is. Probably the key takeaways out of this is it's a 4 fibre pair system. It's over 13,000 kilometres fibre. It's delivered, it's capable of 72 terabits. Within 10 years, it will be estimated at 100 terabits. So that will increase. We've had that 300-fold already in the last 20 years, but we don't expect to hit that in the next 10 years as we're hitting Shannon's limits. But most pleasingly out of this, it's probably for the Pacific Islands. We're seeing Tokelau and Kiribati is now being connected. And as they grow, I think this is what both Robert and Alan's mentioned, it's a greater demand for satellite connectivity for diversity and resilience. But as you said, with the Mpower to provide last mile connectivity into some of the hubs where maybe we are as a cable system. Next one, please, Alan. This is the progress to date on our next cable. Most of it, probably the hard work with the landing stations is mostly complete. There's a bit more work to do in Tokelau and Kiribati. The cable manufacture, which is been held up with COVID like everybody else, but we've done pretty well. As we said, it's 3/4 of the way complete, and we have loads already happening on freighter ships now. Thanks, Alan. This is the marine survey. The main mention out of this is just to show that it's on the great circle distance between Sydney and LA, which will make us the lowest latency cable between the 2 points by far, probably about 10% lower than anyone else. So I guess when you add that with some of the Mpower low latency, that will all add up to Pacific Islands if they want to reach those main data centers out of US or in Australia. Thanks, Alan. It's probably just worthy to note on this that we were probably a little bit different than others. Most cable projects, the marine survey goes along with the cable supplier. We did it differently, where we did the marine survey separate. It helped with our process of the tendering process for the cable, because there's a lot more information given. So typically the surveys are done by the cable manufacturer, but we did it the other way, which gave the tenderers a lot more accurate information to bid on. Thanks, Alan. Just a couple of points. A lot of data obviously comes out of the US. We've already got 2 cables that go into Portland, Seattle up in north. Silicon Valley is served by Morro Bay in California, so you can see the number of data centers in those areas. We've got POPs in San Jose and New Palo Alto and Silicon Valley down at 11 Great Oaks, so we get to those in Silicon Valley, and we extend down to LA region now, but with the new cable going in there, that'll be a whole lot more increase into the One Wilshire's and Equinex's at 600 West 7th. So with that, Southern Cross operates an ecosystem route 16 POPs, and with this we'll add another 5 to it when it comes on with next. Thanks, Alan. Just a couple of photos of this. It's probably more familiar to some of you guys. This was our Savo landing, which has been the great work we've had with in working with the assistance of the government of Fiji and the contractors, McCann Consulting and Hibbard Consulting, and some of those that have been around for with lots of experience. The top right photos showing how we've got on top of the plinth our modular cable station constructed by DXN in Perth and transported, installed over the Christmas period. It stands and shares with the Suva Savo cable, which is installed along with the Tui Samoa project. So the very similar modular station, which will be deployed on Kiribati, which will be that same sort of style of ship in and install. The other one's just the duct work that shows some of that happened on the landing. Next one, please, Alan. And there's a pretty happy crew. Thanks for the CCB and Vico guys. It's really just showing the bulkhead being placed on the shoreline and also celebrating the ducting and the completion of the bulkhead down to the manhole. Just a couple more to go, please, Alan. And for some of you satellite folks, probably not so much to see this, but this is our manufactured cable. It's being loaded into freighters. Into those tanks, it's about 2,500 K of fibre in each of those tanks. That's in Calais being loaded. We're about 50% loaded, and it's on its way. Next slide, please, Alan. And on the same ship, this is our repeaters being racked in place as they load onto the ship and offload. It's about 240 repeaters will be in our system. So that's all very exciting for us. Next one, please, Alan. That's about it. All right, so look, that was a bit of a quick run through. There's many more photos and much more we could tell about that, but this is a satellite. We really were very pleased and excited to be invited by SES. We've worked together on a couple, and they're helping us out with some of the deployment of our next, so we know what they can do. I would like to acknowledge the teamwork in the project for us, and especially from the Pacific partners, landing parties from Teletoka, Tokelau, and BNL in Kiribati, and the government of Fiji, as well as many others. So in summary, I guess we've covered a lot about the connectivity, but as we live in some of the most beautiful parts in the world, it also comes with challenges of distance. So I guess our point is there's no one single solution as well. We work together with the satellite guys, and as long as we can provide for the Pacific the sort of capabilities and connectivity that we sort of take for granted in other parts of the world. So thanks for that, Alan. I'll pass over to you.
Thanks for that, Neville. Sorry, I'll just close up. This is just one example of how satellite guys and cable operators can work nicely together. And at the end of the day, we're here to bring a mesh of connectivity out for the Pacific, and we're here to provide choice. There's a myriad of connectivity options, and I ask that our Pacific brothers and sisters do their homework and investigate the options available to them, and we're happy to work with you to try and find the best solution for your needs, and work together to help push this digital divide. So thank you for that, Phil. I'll pass back to you.
Cheers, Alan. So the next presenter will be Robert Schubert from Intelsat, and he'll have I'm pretty sure he'll have a different perspective. and I'll let Robert carry on.
Thank you, Phil. I'll just share my screen. Hopefully you folks can see it in all its glory.
Yes.
Okay, fantastic. All right, folks, I've noticed a couple of new faces or new names that I'm not familiar with. So what I'll do is just quickly take you through who Intelsat is for those of you who do not know the brand. Intelsat is a satellite operator, much like SES. We have been around for about 65 years, and we fly about 50 satellites in geostationary orbit. What you see in front of you are the market segments which we service, starting from right to left. We look after government. We're spending a lot of time working with the government sector, predominantly defence, in the United States as well as Australia, but more recently across Asia Pacific, we're working with Five Eyes allied nations to develop satellite solutions for their requirements. In the media sector, so if you are involved with anything to do with pay TV, direct to home markets, or if we are looking at contribution to cable head ends or satellite news gathering initiatives, we satisfy that media market. The networks market is really what Intelsat and PITA is all about. PITA, who looks after the telecommunications and internet service providers, we find ourselves doing most of our work in this area, where we're supporting telcos and ISPs with satellite trunks, cellular backhaul solutions using satellite as backhaul. So mobile network operators are very important to us. When it comes to provincial connections, using Wi-Fi hotspots again, or enabling Wi-Fi hotspots, I should say, with satellite backhaul, again, we satisfy those requirements. As SES spoke to disaster recovery or business continuity projects, we also look and work with cable companies or directly with telcos who have got an interest in providing business continuity. And this presentation today will really focus a lot more on enterprise networks, and that's what I'll be speaking to in some detail as the presentation continues. The other two market verticals for us are relatively new. Mobility, that's all about ships at sea, trucks, planes, putting terminals on board those moving vehicles so that they can remain connected to broadband. You'll hear terms like comms on the pause or comms on the move when you speak to the mobility arena, but certainly ships at sea, fishing fleets, etc., have got a substantial presence across the Pacific, and of course it should be an area of interest for the team. Commercial aviation, a brand new division developed within Intelsat, and that's really come with the acquisition of GoGo, and I'll touch on that as the presentation unfolds. The interesting thing when I reflect on the theme of the presentation today, and that is the new reality or how we've survived the COVID period. I must say that out of all of these verticals which I've got here in front of you, clearly commercial aviation has suffered dramatically for us. In the mobility space, the cruise market obviously has taken quite a hit, but in the networks area, that's where we've seen probably the greatest growth potential as a result of a pandemic like we've had with coronavirus. We've clearly seen the unconnected of our countries reach out and desperately cry out for connectivity. Alan spoke to the remote islands. That is a classical example of that. But when we look at specifics like children at school or those health clinics, they have been dramatically affected by coronavirus. And again, I hope that the governments have been paying attention to that and reacting and being able to recognize that satellite can provide a rapid solution for those people that are on the fringes of any community. So moving along, the last 12 months for Intelsat. So what have we been doing during the pandemic? Well, we've been exceptionally busy. We've been launching and building new satellites as we usually do. So if we look at the space plane across the top horizontal bar, we've been working to develop a response to the C-band acquisition by the FCC in the United States. We've been building new satellites to satisfy that requirement moving forward. We've also been doing something very interesting by way of non-GEO satellite integration. I think what we saw in the previous presentation, where MEO and GEO is working together, and what we see is that many of our customers across the globe, and certainly across the Pacific, will inevitably entertain LEO satellite operators, MEO satellite operators, and GEO satellite operators. So what Intelsat is doing is we're working very hard at how we can help our customers in the integration of those various altitudes and bring them together as a service. Now that could be by way of SD-WAN or other forms of integration, but we're certainly working to ensure that when our customers are looking to satisfy a broad range of requirements and applications, then we can satisfy them by working with Intelsat. Further to the right, you can see a term called Sds Satellites. Well, that is the launch of our next generation software-defined satellites. And for those of you that have been familiar in the mobile network operator area or cellular industry, we've had software-defined radios for a long time. Satellites are going down the same path. So as a satellite is deployed, we have the ability to manage its configuration from the ground, and we can move power, we can move capacity to those markets that need it most, therefore satisfying our business case and certainly that of the customer base on the ground. In terms of ground and terminals, again, much like Alan's presentation earlier, a lot of the success of the space segment will be directly linked to what's happening on the ground. Now with Intelsat, we've been working on a number of initiatives. I already mentioned SD-WAN, but Intelsat was very successful at the Metro Ethernet Forum. We were able to secure a few awards and demonstrating how SD-WAN can interface successfully with satellite connectivity, providing another form of access for enterprise and government customers especially. So a customer can have a Wi-Fi connection or a broadband ADSL connection, but additionally have a satellite access point connected to their SD-WAN, therefore providing further resilience or a better class of service. The other area that we've been working on by way of our roadmap is our strategy moving forward with 5G. As we know, 5G is much more than just faster broadband for your handsets. It is an all-encompassing program affecting all elements of telecommunications. And as we move forward, we see that more and more edge devices will have computing powers at edge devices, I should say, and therefore the ability to connect to those edge devices, providing connectivity or backhaul solutions will ensure satellites prevailing application in those areas. SES has already spent a fair bit of time speaking to flat panel antennas and how they will play an important role in the success of the space segment moving forward. But clearly, as we see the volume of flat panels being produced and their prices reduced, their application will certainly bleed into a whole bunch of new market segments. So to that end, what is our latest announcement, or one of our biggest announcements coming from Intelsat during the COVID year? Well, it's been the acquisition of Gogo, which is a commercial aviation organization. In fact, it's considered the globe's largest commercial in-flight broadband and entertainment services company. I'm sure we've all had the pleasure in the past of getting on a plane and switching off our computers and watching movies and enjoying in-flight hospitality, but now you can stay connected, keep doing emails, surfing the web, or perhaps chatting with family whilst you're flying from one country to the next. And that's what GoGo does. Intelsat acquired the business for $400 million. It's added a lot of people to our staff. But importantly, GoGo is also extremely interested in Asia Pacific. And if, as PITA-based service providers, your airlines are looking for in-flight connectivity solutions, don't hesitate to give me a call and I'll connect you through to GoGo. Interestingly, you know, the aviation sector, as I mentioned earlier, has been hit quite hard by coronavirus. But Australia, New Zealand and the Pacific, I think, will emerge out of this sooner than other countries will. And to that end, hopefully our aircraft industry will also recover rapidly behind it. So in terms of my presentation today, focusing on one of our latest innovations, it really comes off the back of coronavirus as well, and where we saw the need and potential for connectivity. Now, Intelsat has, for the longest time, been providing a great deal of flexibility to the Pacific community. We all recognize that many of the Pacific Island nations have got existing infrastructure. They have their satellite earth stations, they have satellite capability with their teams, and they can procure bandwidth from an organization like Intelsat and use their infrastructure to provide their customer base megabit solutions. And that may be driven by sovereign requirements to ensure that services remain secure in your country. It could be as a result of your Telecommunications Act and ensuring that services land in your country and then traverse a cable system to the internet or what have you. But in some instances, what Intelsat found is that our customers require managed services, whereby Intelsat provides them a wholesale megabit solution such that internet connectivity or even enterprise solutions can be achieved. Now, that may be as a result of the extreme pressure that many of our Pacific-based telcos are under. Their technical staff one day will be installing broadband services, working on mobile networks. They'll be working on deploying fiber or microwave towers. So they're stretched. And also having satellite capability may be difficult to get access to. And what we certainly found during the coronavirus period was that many projects which were being undertaken faced extreme challenges when it came to securing skilled staff to be able to undertake certain works. So with that, Intelsat felt it appropriate to simplify and ensure that at least enterprise VSAT services can be provided across the Pacific effectively and rapidly. With that, we developed a further segue to our Flex Enterprise services, where Intelsat uses its infrastructure around the globe, our teleports located around the planet. They all integrate with our spacecraft, our Epic high throughput satellites, and with the iDirect platforms which we have at all of our facilities. Using the iDirect Velocity platform, we can provide subscriber-based services. And today what I'll be speaking to you about is the latest adjunct to the Flex Enterprise family, which is called Flex Enterprise Hosted. So with Flex Enterprise Hosted, what we've done is we've really simplified the task of being able to supply broadband services to an end user. May they be an enterprise customer, may they be a government end user, may they be a tourism operator, may it be a Wi-Fi hotspot. The hosted product allows an internet service provider or a Pacific-based telco to be able to deploy and enter this market space with the least amount of risk. And that's what we have ensured with the hosted product. We've completely de-risked the ability for a Pacific-based telecommunication service provider to enter the satellite space. So with the headline messages here, what we have done is, using our infrastructure, we will be able to provide wholesale data or broadband services. The key thing here is that there is no wholesale capacity commitment. You don't need to go out and pre-commit to 100 or 200 or 300 megabits. You simply start with your first customer, and you simply start by adding your very first VSAT antenna to the customer base or the new business or line of business which you've just started. So you can expand at your own pace as the opportunities come along, or you can begin to target those market segments or those verticals in your country which perhaps are not covered today. That could be, as I mentioned earlier, the tourism sector. It could be a remote community which has absolutely no services today. Take one of these hosted VSAT services, create a hybrid Wi-Fi solution, and you can provide a service to that village rapidly. So the benefits clearly are that you will be getting a KU band enterprise grade service. It'll be high speed and absolutely low cost for your customers. So the way that we looked at this service was to ensure that it is fully productized. So we have added, or as part of a service wrapper of the hosted product, we have been able to ensure that a service management platform or portal is offered to you. So it is an extremely intuitive and very simple platform and portal to use. You can add, you can remove customers from your network. You can appropriately and rapidly apply the correct service profile. Maybe a 5x2 megabit service, 2x1, or a 10x3 megabit service with an appropriate download package associated with it. All of that is available to you at your fingertips, so you can control and drive the network. Simply put, you will be able to have access to a VSAT terminal, which will be your accountability to install and configure at the remote end. It'll help you with the service assurance elements and allow you to provide that 24/7 support which customers require. On the right-hand side of the ledger, Intelsat will continue to do what it's always done, and that is fly satellites, manage our teleports, and ensure that the network that your end user is ultimately getting is first class. So to wrap up the presentation, what we think we will see by way of this new, could we say, evolution of Intelsat product, it will allow, I think, many of the telecommunication service providers in the Pacific to enter the satellite space, to allow you to provide solutions to the most remote parts of your country or to businesses that reside in your country, a service which grows with you. We're not going to make you drink from a fire hose. We're going to allow you to set your pace and how you grow your market. And I think it comes at an extremely critical period, coming on the back of coronavirus. I think many governments have seen that their schools, their health clinics, and remote communities have suffered the most as a result of a pandemic. I hope that we've learnt from that, and that we can actually go and implement solutions because they're available today. And with that, I would like to thank Fred and the team from PITA for giving me a chance to present Intelsat solutions and how we've been able to redefine them for the pandemic period. Thanks so much.
Thank you, Robert. Those are very good insights from a company that's been in the business for 60 years. And I remember cutting my teeth on the ops reps meeting in Intelsat in the very, very early days. So I'd actually like to welcome back OneWeb. They did have a presence at PITA a few years ago, and we understand some of the challenges they had. But welcome back to OneWeb, and they'll give us an update on their broadband connectivity options that they're proposing for the market. I'll hand over to Bala Balamurali.
So thank you very much for having OneWeb back. Yeah, and as you quite rightly pointed out, yeah, we're sort of back. We've been in the news a bit last year with the reorganization that we've been through, and we've successfully completed that. And I'm happy to say that we're more in the news this year for the various successful launches that we've already carried out, and on track for almost monthly satellite launches going forward from here on. So just for those who are not familiar with OneWeb, just a quick recap. OneWeb's building a global constellation of some 650 satellites in our first generation, supported by a ground network that we will also own and operate, with over 40 gateways around the world. So one of the good things being one of the latest speakers is colleagues from SES and Intelsat have talked a little bit about the orbits and the benefits and the challenges of the various orbits. And quite rightly, being a low Earth orbit operator, we will need several gateways, and we have a number planned in the Pacific Islands so that we can fully cover the region with several gigabits per second of capacity. Just a quick update on the reorganization that we went through last year. Now we are owned by Her Majesty's government and Bharti Global as the two large shareholders. We still have SoftBank and Hughes as significant shareholders in the company too. Just goes to show the belief and the confidence they have in the system and the people behind the company. And I'm happy to say we're now almost totally back on track with a slight delay in the launch, and with what's being planned right now and the satellites that are being launched, we expect to be offering commercial services over the 50 degrees latitude, starting from about Q4 of this year, and gradually increase coverage from there to provide full global coverage by the end of next year. I'll quickly go through this slide, which is, we've covered this, various other presenters have talked about the orbits. So OneWeb is in the 1200 kilometer orbit, and yes, our latency, the satellite latency portion, as a result, is around 50 milliseconds. However, what we have calculated with some degree of precision, with satellites, ground networks, gateways, and POPs, we are confident in offering a service to the end user that is less than 100 milliseconds in latency. And what it does, of course, as you know, will open up a whole range of new applications that we can provide. High bandwidth and low latency means we're making it possible for our customers to start using satellites for cloud-based services, gaming, and various other. I mean, we may be a little bit ambitious with gaming. If you're a mad gamer, 100 milliseconds is too slow, but there are various other enterprise applications, cloud-based applications, where we feel we can be a real game changer. One other thing we've managed to achieve is we've fully restarted our satellite manufacturing facility in Florida, and we're back to manufacturing 2 satellites a day. And I think in that sort of assembly arrangement we clearly, for the class of satellites we make, we must be amongst the lowest cost in actual satellite production, and that will not only sort of carry on for the current generation. We've also made plans future generation satellites, and I'm not talking about it today, but just to mention that this is an ongoing process, satellite manufacturing, launching, and offering services. Very quickly, how the system works. I haven't got the luxury of a commercial technical double act like my friends from SES, but what I would like to do, if I can, try to show you this video that probably summarizes how the OneWeb system works best. If you can't see it, then I'll flick back to the presentation. Just give me 1 second.
Since the beginning, the World Wide Web has never been worldwide. But OneWeb's new and truly global 5G-ready network will fix that. Say you're working on the edge of the world and need to do a video call. Perhaps you're mid-ocean or mid-air. Wherever you are, you'll have a signal. OneWeb will connect your device through a customized terminal that can be as small as a briefcase and just as compact. Whatever your location, the terminal encrypts your data and sends it at high speed to our satellite fleet passing overhead. These spacecraft are radically innovative, built in our own factory at 1/50th the traditional time and cost, shrunk to the size of a washing machine, yet engineered to deliver powerful throughput. Month by month, we're growing our satellite fleet, and soon we'll have not only the global spectrum rights, but the network reach to deliver truly worldwide coverage. And here's the revolutionary part. The fleet will be in low Earth orbit, 30 times closer to Earth than geostationary satellites. This gives you a stable, real-time connection with no interruption or annoying lag. What's more, our fleet always keeps moving, orbiting in a constellation design that creates seamless coverage. Each satellite uses a set of beams to cover an area the size of Alaska. Terrain is no obstacle. From its flight path and pattern, our fleet can always find your signal, so we can get you online from even the trickiest locations, with look angles that geo-satellite broadband simply can't deliver. We maintain high-grade system resilience from 2 ops centers using state-of-the-art ops concepts. Cloud architecture gives us powerful scalability and control remotely. For example, we can remove satellites at the end of their service life, so that the only trace we'll leave in space is on your screen right now. Now back to that video call of yours. We beam your data back down to Earth to our nearest satellite network portal. Then via one of our point of presence gateways, positioned in secure locations trusted by global providers, it re-enters the web. The journey you've just watched takes, at most, 1/10 of a second. And there they are. Your video call is good to start, whether with colleagues or your family back home. So you need never be out of signal or out of mind. OneWeb will connect you from unconnectable locations and keep you productive on the move. It'll be a breakthrough year when OneWeb technology creates real human progress, connecting everywhere, for everyone.
Okay, so 650 satellites in a low Earth orbit, 588 operational, and the rest in orbit spares. We connect to the connect satellites through 40+ gateways on the ground, KU band, user links, and KA band feeder links to the satellite gateways we call satellite network portals. We have globally for the KU band user frequencies, we have high priority or highest priority, I would say. I think we've negotiated or coordinated with one of the other operators with whom we had to coordinate, and we have highest priority on that. Ka band, based on where we have the gateways, we work with operators who are in that country where we have the gateway or are affected by our gateways, and we have pretty much completed coordination with most of them, and some last remaining ones are being completed right now. So while we offer a global service, the game is to be as localized as possible. We don't have any approach, any plans to go directly to the end users. We will always work with our distribution partners, and they mostly are internet service providers or Viasat or telecommunications operators in the various target markets that we are operating in. And the plan, therefore, is to fully comply not just with the regulatory stuff, but also, the local government legal requirements, whether it's about user terminals or they're about landing rights and so on. And I'm sure that's what everybody does, but we've made it or that we have partners who can achieve that for us. And that's a point I'd like to make, because we are still actively looking for partners in certain regions of the world, including the Pacific region. So hopefully, with this presentation, we would have sort of reminded everyone about what's available and what we plan to do in the region, and the benefits of the technology. So we would like to hear from potential partners in the region as well. Quickly to go through the satellites, we have these are fairly small satellites, about 150 kilograms each, in a low Earth orbit, with the beams more like Venetian blinds. There are 16 of them per satellite, and each satellite is expected to be in view of a user terminal for about 3 minutes as it passes overhead. So there'll be beam-to-beam switching and then satellite-to-satellite switching, which is made possible by antennas, which basically track one satellite or more at any one time, and then use the best possible link to provide the service to the end user. The capacity per satellite is fixed in the current generation, with using about 250 megahertz of bandwidth in the forward link, and that sort of gives about 450 megabits per second as the overall capacity per beam. The user terminals, therefore, will be able to provide, they're configured to provide about 195 megabits per second in the commercial versions in the forward link, and about 30. As I mentioned before, the size of the satellites, that almost the size of a dishwasher, and we pack about 34 to 36 satellites per launch. And we've completed 5 launches and are now preparing for the 6th one before the end of April. The markets that we plan to serve, the traditional satellite markets, as you can see, maritime, aviation, but also the enterprise, government, and cellular backhaul markets, where I think low Earth orbit, low latency, high bandwidth connectivity can make a big difference. As I mentioned before, even though we are a global system, we have, in every sense of the word, from commercial, regulatory to actual user experience, pricing, we try to be as local as possible. So with that in mind, we are also working closely with our partners to deliver services to governments, schools, government facilities in very remote areas, and also making it possible for enterprise users such as banks and mining sites and the usual enterprise customers who are located in remote areas, but now with a more affordable and higher bandwidth and low latency service. As you know, low latency also makes it possible for us to offer a certain cellular backhaul capability, including voice, for mobile operators, albeit not with the sort of massive capacity that you will require in the city centers, but in remote areas, I think our system and our capacity will work best with where you need cellular backhaul with voice capability or low latency capability. From our progress, as far as progress goes, as I mentioned, we've had a number of successful launches in the last few months, and we continue to grow the network. The ground network is also growing nicely. We have more than 20 of the 40 gateways are already either complete or very close to completion, with the rest being rapidly built out. So the ground networks, the connectivity between the networks, all of this is what makes it possible for us to offer a full low latency global service. The rollout itself, as I mentioned to you before, we will have commercial service over the 50 degrees north this year, before the end of this year and Q4 this year. But we're also planning a gradual rollout that might start offering certain parts of the Pacific Islands might actually be able to enjoy OneWeb services as early as sort of from mid next year, and rather than wait all the way to the end of next year. If there are any questions on that, and if I have sort of specific locations, then we may be able to tell you precisely when service will be available in those areas, and you can drop me an email then for us to give you a more precise timing on that. Just a quickly touch on user terminals. As fellow speakers have mentioned before, the end game plan is to go for flat panel antennas, but we're launching our services with the dual parabolic antennas. Dual parabolic as in, you know, 2 antennas, so that you have continuous service, while the first antenna tracks the best satellite available for the first 3 minutes. The second one picks up the second, and then therefore the handover, a seamless handover between the 2 antennas to keep the user experience, you know, as a seamless, uninterrupted connection. So we have parabolic terminals for enterprise use as well as maritime use, and we will also be launching with our commercial service launch at the end of next year a flat panel antenna, which will be about a third in terms of performance, but and also, you know, it's the convenience of having a flat panel. Therefore, yeah, we think it can still be a very useful addition to the portfolio terminals at a very early stage, starting as early as Q4 next year. And there are various other projects in the pipeline that will deliver faster, better, lower power terminals in the next year or 2 after we have full commercial launch. Just one final slide about responsible space. I mean, many points have been made about the number of satellites required for LEO constellations, and that is just a fact, because we are closer to the Earth, we need more satellites. Therefore, what we do with those satellites after they reach end of life is a very important question, and OneWeb has driven this initiative in terms of responsible space, started by our previous chairman, Greg Weiler, as well as you know, we've continued our current generation plans as well as future plans with that goal of not leaving much of a trace once our satellites reached end of life, so that they are properly deorbited and not leave any clutter in space. There is more details available if anyone's interested in that on our website, as well as by email if you'd like to see more. That basically is the end of my presentation. I'm sorry, it's a much shorter one than the previous ones you've seen. But happy to take any questions or reply to you by email.
Thank you, Bala. We're a bit stretched for time due to the late start. So I'll ask Dennis to wrap it up with his presentation on the choices between LEOs and GEOs. Over to you, Dennis.
Okay, so what I wanted to do first, I know this is not quite as advertised, but I just wanted to do a quick take the opportunity to do a quick update on Viasat, because I guess we haven't met for quite a while. So anyway, so the latest is we're up to nearly 6,000 employees, founded in 1986. We have 45 offices globally, and that includes 3 in Australia. We've got an office in Sydney, Melbourne, and Canberra. Head office is actually in Melbourne. We're up to 2.3 billion in sales. We currently have 4 satellites in orbit, and soon to be 5, and that will be the first of the new Viasat 3 satellites. And we're listed on the NASDAQ. Next slide. Yeah, you just got to sort of click your way through this. I guess we've been talking about this for quite a while. I think we've sort of led the way with the high throughput satellites in Ka band. I think it's fair to say that Viasat 1 was the first of those significant high throughput satellites, and it was about roughly 140 gigabits. And since then, we just we've through spending a lot of money, billions of dollars in investment on space and ground infrastructure, we keep improving the capacity with orders of magnitude. Viasat 2 was launched about 3 or 4 years ago, and it is around 300 gigabit per second capacity. And then soon to be launched, the first of the Viasat 3 satellites is more than a terabit capacity. And so, yep, next, sorry, before you do that. Yeah, that comment up the top there, the satellite company, I mean, if I turn the clock back 30 years when I started working with Scientific Atlanta, satellites sucked. It was, I won't say embarrassing, but it was super expensive, and it was the choice of last resort for connection, just because of the expense and pretty minimal capacity and slow speeds of connection. So things have changed dramatically since then. Okay, next slide, thanks. Oh, just click that. Oh, yeah, it's all right. I haven't got control of this. You want to just back up to that last one? I'll just, yes, I just mentioned there, Viasat 3, we've got the first one is this year, and then by the end of the year, we'll have the first 2 Viasat 3 satellites, and then mid next year, we will have the satellite for this region, the Asia Pacific Viasat 3 satellite. We're already working on Viasat 4, and that's going to be another giant leap in capacity, and it's reported that it'll be around a 4 terabit satellite per satellite. Okay, thanks. And that's just a snapshot of the sort of services that we do. previous presentation today. I guess it touched on most of this. We're also in the Wi-Fi, like IFC, in-flight connectivity, and anyone that's flown on Qantas, I guess, wind the clock back before the pandemic, that's our service using the NBN SkyMaster satellites. So the Qantas actually use our service for that. And just domestically, because we're not quite there yet with the coverage. Once we get Viasat 3 up, we'll have global coverage and we'll be able to extend that service for Qantas, for example, wherever they want to fly. We also do maritime, and we've done a lot actually in the right hand of the slide there, up there, connecting the unconnected. And I know I've talked about this before, but that's been going ahead pretty well in Mexico and Brazil. We've put many tens of thousands of these services in commission now, and that's really going. That's a good business, and we're providing service to people that have never previously had anything. Okay, I've got also unlimited home internet. That's available in Europe and North America, mostly via Viasat 1 and Viasat 2. And that's enough of that one. Thanks. Next. Okay, next we're just going to get into the just some comparisons between LEO and GEO. So I guess the main challenge is still we've that 95% of the world population live on only 10% of the world's land, and that's a big challenge. Basically what it means is the challenge is to actually efficiently focus your capacity where the people are. And so in the LEO, what we see there is that we see LEO as complementary to GEO for latency sensitive traffic and also for polar coverage, which we can't provide services on the poles. However, you need hundreds of satellites to cover the globe using LEO. GEO solution, I guess in comparison, we're using tried and proven technology, flexible system which matches supply and demand. We only need 3 satellites to cover the globe, not hundreds or thousands or tens of thousands. We get a 15-year life expectancy from each satellite. We get a much higher efficiency capacity usage because we can focus the capacity to where it's needed. Compared to LEO, the challenge for LEO is a lot of the time satellites are flying over water, and so it's not very efficient from that point of view. Okay, next satellite. Thanks. Sorry, next slide. Click on that. So the fundamental productivity challenges. So where to put satellites so they're useful. So that's, I think, one big advantage we have with the GEO satellites. It's basically set up to provide capacity, as I mentioned earlier, to where the people are. And also low probability of collision. Obviously, GEO satellites don't collide with each other. We've probably read different, stories about those possibilities as more and more LEOs enter orbit. The useful life, GEO is 15 years. I've heard 3 to 4 years is a typical life of a LEO satellite. Next. And also the big thing really is controlling interference among the different NGSO constellations, LEO and MEO. It's quite a challenge, and it's complex, and I guess it needs a lot of work. And every NGSO constellation interferes with every other NGO constellation, so there's a lot of coordination issues needed as well. Okay, next, thanks. Okay, so implications of bandwidth demand for LEO. We're just talking about LEO here. You need about 35% more bandwidth each year to keep the same number of subscribers with the same service. That's what we see and has been our experience in our business. It's like you need to provide 35% more bandwidth year on year to keep the same customers happy. Otherwise, if you don't provide that 35% more capacity, then you've got congestion, which impacts, as we know, on customer happiness, and latency can also get worse with as things get congested. Next. So for the same satellite capacity, 35% more satellites, and that compounds annually. So what we're saying there is you just need to keep launching more and more satellites to keep up with the demand. And the economics get worse because the bandwidth growth is, with bandwidth growth 35%, less price increase, less productivity. Last. So improving productivity with more satellites at lower cost, very hard due to diseconomies of scale. Next slide. So I guess that's the that's probably I guess this is a representation of 37,000 satellites. Somebody there in the LEO orbit. It's a proliferation, and it's going to be quite a challenge if it ever gets to this sort of number, just to keep things, keep things organised. Next. So Morgan Stanley research. So we've got some cost per gigabit per month table there. So in the SpaceX, we're looking at $10,000 to $25,000 cost per gigabit per month. HTSKU is up around the 30 to 35. Viasat 2, we're down to much more cost effective. And then Viasat 3 is down below $5,000 per gigabit per month. So the efficiency is very different, very much better with GEO UHTS satellites. Just click again. I think there's a little thing there for Viasat 4, which is going to be 4 to 5 terabits, and that's coming in well under the Viasat 3 cost per gigabit. Okay, next slide. Next, the last slide. So this is just a kind of a summary of the comparisons. So ultra high capacity geosynchronous advantages, steady increasing in bandwidth per capital investment. You can keep pace with the per capita bandwidth demand. The regulatory certainty for GEO satellites do not interfere with each or collide. So there's a lot more certainty with regulation. I think I think there's a lot of, I guess, there's a lot of talk, if you like, and you know, there's some uncertainties really ahead of us in terms of LEO regulation of LEOs, especially when we start talking about 20, 30, 40,000 LEO satellites in orbit. Another advantage of our geostationary, our terminals are low cost and low power compared to others in LEO and MEO. In fact, MEO are probably, I think, the most expensive still. Essentially, we get global coverage with Viasat 3 with those 3 satellites. The disadvantage for us is we are higher latency, but we are actually working on mitigating that with a hybrid terminal using either terrestrial or LEO connectivity. So the LEO advantages on the other side there, we've got lower latency is the main advantage. The LEO disadvantages, expensive user terminals with higher power requirements. And I think it's fair to say that LEO terminals are probably at least 3 to 4 times more expensive than what we're currently using on our Viasat 2, Viasat 1 and Viasat 2 satellites. Geographic distribution of bandwidth due to orbits. That is, as I said before, it's just inherently inefficient because of the amount of time they spend over water. And short life, 3 to 4 years, due to multiple factors: radiation, atmospheric, drag, lack of redundancy. And the regulatory uncertainty, I think that's still to play out in full. We've seen some of it. There's been a lot of it in the press, and here in Australia, I know ACMA are all over it, and I don't think it's been resolved yet. So just keep watching that space. Orbital debris, interference with other NGSOs, congestion, and orbit overlaps all become issues. Regulatory constraints on per satellite capacity due to interference with other, limits to grow in the number of satellites due to safety and congestion. So basically what we're saying there is it's possible that we'll reach a point where there's just no more space, and so you can't grow. Whereas we don't have that problem because of what we're doing on a single satellite, like Viasat 4, for example, up to 4 terabits on a single satellite. Okay, any questions? Any of those LEO and MEO guys want to throw some rocks at me? Or?
I'm sure they do, Dennis, but I think we've run out of time. But I'll thank you for zipping through your presentation. All this collateral will be available on the PITA site after the conference or during the conference if anybody wants to review and ask questions directly to Dennis. That's always the option. So thank you to all the presenters for this session. It's the last of the day. And I'm looking forward to drinks immediately following this. But again, I want to thank our platinum sponsors, Welshman Keen, Speedcast, SES, Maser, Communications Data Group, Pacific, Telstra, Docomo Pacific, Intelsat, and WCC Group. Again, acknowledging those, without them, it would be hard, it would be extremely difficult for PITA to put on this conference. Enjoy the rest of the evening, those who are in your evening or just entering the late afternoon, and we catch up tomorrow. Cheers, everyone.
Thanks, Frank.